Hello, everyone. I'm Josh Bond, and my app for this semester is called GuessWords. It's a compound word game for kids. It has two pictures, and you try to deduce the word for each picture, and that forms a compound word. And my motivation for creating this game is, well, let's just look at what's out here. That kind of tells the whole story. Many of these games are aimed at adults. If you play them, the puzzles are pretty difficult, and if you pick just one at random, it's not that hard to usually find some sort of complaint about pop-up ads, coins, or otherwise earning coins to advance in the game. And people get tired of that. Kids get frustrated. My own daughter got frustrated with this. Here it is again, has too many ads. A lot of these people in some of these reviews complain that the ads slow their phone to a crawl. And my thought on that is it's probably not the ads. It's probably some extraneous activity, because Google lets some shady stuff into the Play Store. Who knows? It could be mining Bitcoin for someone, or who knows. But here's another one. Probably some complaint here. Yep, watch ads for coins. I mean, this is what you get, and I understand why developers do it. They need to monetize and make a living. But I thought I would do this, and my daughter could play a game and have some fun with it, and I would get credit for filling this assignment. It's kind of a win-win for everybody. And she helped me beta test this by playing through, and she really enjoyed playing through the puzzles. I think there's 11 or 12 puzzles that I've made. The solution area and the pool area, most of this is pretty self-explanatory. This is the general gameplay of how it all works, and you click a button and it appears up here in the solution. But the code refers to the solution area, and it's referring to the solution letters. Either they're blank or they have a letter in them. Or in the pool area here, this is the pool of available letters. So the app takes the letters jump rope, the word jump rope, split, and take these letters, and so if there's 8 letters here, we have 16 letters in the solution. It's always double. 5 letters in the solution, we'll have 10 in the pool. 6 here, we'll have 12. Great thing about doubling any number is you get an even number, which makes it nice and neat for our rows in this relative layout here. Now, I think the next one, demo the app, and that makes sense. We'll just walk you right through it here. The gameplay is just like I said. You click J and U, and we fill in jump rope, and we'll fill it out wrong the first time. Well, let's see here. There, that tells you what happens there. And then the positive affirmation that you've completed the puzzle. And we can use a hint, remove all the wrong letters from the pool area. So watch it, and you see all the wrong letters go away. And then let's reveal a solution letter. Another one. See, it deduct a hint. I deduct a star each time. You can't get to a negative number. That's good. Also notice that you can't click remove all again, because once all those letters are gone, you can't. It doesn't make sense to remove them again. So we shouldn't let the user do that. We can keep going here, and once we get to here, we cannot use another hint. That makes sense. You can't reveal. I think anybody playing the game, when there's one character left, then you just need to click it. You don't need to click a hint, so I don't let anybody do that. And this is how the game works. You can continue to progress through all the puzzles, and here they are. The game tracks the highest puzzles, so from that we can deduce where you are in the game. You can go linearly. You must go linearly through the game, but you can go back to any puzzle out of order if you want. Just click it, and then you go back, and sound on, sound off, toggle there. The solution and pool buttons, we talked about that, and here they are being generated. The controller is the main game activity, and the game model here, as you might guess, that's the model. So the controller it has a button factory, and it tells the button factory to make the letters based off the solution in the game model for this puzzle, make the letter buttons and the blank buttons, and put them in a list. And those lists, or an array list, is sent over to game model, and it maintains the state of the game. The solution buttons and pull buttons, we were just talking about those. It's important to point out that these lists are not swapping pointers to buttons back and forth. These buttons are Android buttons, and therefore they're an object. And of course, you should know that array lists don't maintain actual objects in them. Instead, it maintains a pointer to the objects. But the point here is that the pointers are not being swapped back and forth. So really what's happening is when you click a T, it disappears. It appears to disappear from the pool area, but it's really just marked as invisible. And then the T becomes visible up here. we're just restylizing the blank button. We're not actually moving buttons back and forth between these two lists. And when a button has a blank string, each Android button you can call get text, and it will tell you what text is assigned, what string is assigned to the button. Here it's T, here it's E, here it's A. Well, here it's nothing. It's an empty string. So the app knows if there's an empty string for a blank button, then it's truly blank. Otherwise, if it has a T, if it returns a T or an E or whatever, then that is not a blank spot. Similarly, down here, we can maintain the state and understand, the app can understand what's happening here, because if a letter is visible, then it's also clickable. Makes sense. If the letter is invisible, the button is invisible, then it's also not clickable. So the app maintains state that way as well. Interestingly, we have a random word popped up here, plow, and you see that some in the game where it just creates a random collection of letters that happens to spell a word. It happens from time to time. The reveal all and remove, we talked about that already. Here's where we store all the shared preferences. A lot of this is exactly what you would expect. If the app restarts and we don't track the number of stars to persistent storage, then how are we going to know what the stars are or where you're at in the game, whether you had sound enabled, that kind of thing. But then some of these are, and of course the highest puzzle, remember that's how we track over here and show what levels have been unlocked. Your highest level is what's green. Otherwise, it's grayed out and you can't click on it. We track that highest puzzle here. The rest of this data is really aimed at hint data. If you buy a hint and then you don't solve the puzzle, so you buy the hint, you do not solve the puzzle, and the app restarts, what happens? Well, I'd like to be able to, when the game starts, it's automatically going to take you back to that puzzle. But if we don't store the data about the state of the puzzle and the hint, then we really can't reconstruct where you were in the game. So we store the solution buttons and the pool buttons in shared preferences, and we store whether remove hint has been called. You remember over here, once we choose remove all, we need to track that because it shouldn't allow the user to click that again. The game model always tracks the extra letters that were added to the solution. Remember, we double the number of letters. Well, we don't have to do it that way, but it's easier. It saves computational power and a lot of loops to just track it in a list. And so if the game restarts, then we also need to know, and we're in the middle of a puzzle, the game restarts, then we need to know what letters were added so the game logic works as expected. Over here, shared preferences, Android buttons are not serializable because in the child classes they replicated class names that were used in the parent classes. There's a lot about that on the internet, but the bottom line here is that shared preferences is fine for primitive values, and that's what you see a lot of here. But for the buttons, I just represented them. I described them so I could reproduce the buttons when the game was restarted. So here we have F, and that's the actual letter that's in the button, and V means visible, I means invisible. So A is the letter, I is invisible. And look here, A is here and it's invisible. Why? Well, it looks to me like A is also in the solution and it's not clickable. See, N means not clickable, C means clickable. Blank underscore means the letter is in the solution is blank. So it's talking about this right here. These would all be underscore C's. And really, C is just the default. You can't click on a blank button anyway. So the A here is not clickable because it was provided by a hint, and otherwise it would be C for clickable. So we might have a T here, and it would be clickable, meaning that the user put it there. But this is where all the data is stored that the game tracks, and this is the class diagram. It's a nice bird's eye view of the code. And before we get into the code, I just want to show you this because I always like to see a high level view. Game button is an abstract class, and we extend game button with letter button and blank button. We talked about those a little bit. The controller here is main game activity, and the game model. Sound is a bunch of static classes. Static methods that we can call without having to clutter the code by instantiating sound. And input output game model delegates a little bit of the reading and writing, storing data to input and output. And the rest of these, hint dialog box extends dialog, and main game activity and level choose in the puzzle class. This is how I organize everything. To me, this made the most sense. And iteratively, as I developed it, I just split things out into different classes until you see the layout here. The requirements. This is how I built it. The app. Create an attractive layout, view the puzzle. The app looked very, very different back then. And I went through each one of these each week, and I moved some of these around from week to week, and I wound up adding some stuff here in the last one to try to find enough to do. But because I got done a little quicker than I thought I would with some of this, it's easy. Hey, it's easy to spend time and get stuff done on a project when you enjoy it, as opposed to some classes where the projects you really don't enjoy. But it's fun to code, and so I got this done quicker than I thought. But the requirements, I mean, there's tons of them, and we can, no sense in going through all of this. I've already covered a lot of these by looking at the app. I mean, looking at the PowerPoint slides and walking you through some of it. But there's a lot that goes into this, into even a simple game. It makes you respect all the apps out there in the Android store, because even putting together something that's relatively simple, seemingly simple, has a lot of logic behind it, especially with the hints, making all of that work. Over in Android Studio, we have let's see, main game activity. This is the controller, and we don't have time to go through 2,000, 3,000 lines of code. That is pretty much what all these classes represent. But a knit puzzle is, by the time all this code executes, then over here, all of this will be displayed just with this executing here. The intent is you get the puzzle number from the main game activity based on the last puzzle that you played. The buttons are generated, and then we have the puzzle image rendered. That would be this right. Whoops. That would be this right here. And at that point, the game just waits on you to click a button. And when you click a button, like let's say you click a letter button. Let's go to the on-click listener and letter button. It moves the button from the solution to the pool, right? Like that. And we talked about that. It's not really moving anything as far as the array lists are concerned, but it gives the illusion of movement. And then the blank button, well, let's look at this first. Letter button, the only way you can solve a puzzle is by clicking a letter button, right? If you think about it, that's the only time, that's the triggering event. You've clicked a letter button. Now, not every time, but eventually by clicking letter buttons you will solve the puzzle. And so every time we click a letter button, we do the first thing we check is the solution full, or are we maxed out? If so, then let's check and see if let's ask the model, do we have a match? Do we have a match between what's displaying here in the view and with the data that's expected in the model? If we do, then we launch puzzle success. Otherwise we shake the buttons and play the bad sound and let the user know they don't have the right answer. Blank button, kind of similar. We have an on-click listener, and it's the exact opposite. We move the button from the solution to the pool. This just controls what happens when we move a letter back. And a little bit simpler than the letter button. We have a little more logic in the letter button. In this sense, main game activity it delegates some of the controlling logic to letter button and game button, since that's really what drives the game. Back over here, puzzle success. This is back in the controller class, main game activity. We have to once the puzzle has been solved, puzzle success, we have to update the model and the view and draw the continue button and the success button. We have to take away all these buttons here if there's anything left. Display a continue button and the success message. You remember seeing that. And then after the user clicks the continue button, then we have even more stuff to do. We have to reset a lot of the data in the model, because if we don't, the view won't be consistent with the model. And so that's pretty important. Otherwise, nothing's gonna make sense. And a lot of what's left are just helper methods that drive what I just described. I just described really the heart and soul of the algorithm of the app itself, between this and the letter buttons and the blank buttons. But then the rest of all of this, and in many other classes, it's the helping message, it's the helper classes that make all of this possible. Like when we are the app's restarting, we have to process the save buttons, process everything that we have stored, if we have anything stored. And speaking of that, over in game model, we have everything that's represented in the game, the data. Some of this is delegated out to the input output class, which is right here. And you can see here that this is the shared preferences data that we've already seen. This is sort of the back end of what we're doing. If it doesn't exist, then we want to create it in the file here, because see, that's what we looked at earlier. If that file doesn't exist, it's going to be created, and this handles all the input and output. And puzzle parser, we haven't talked about that. Over in puzzles.xml, this is all the puzzles. This is the raw puzzle data. This is how the app knows a puzzle exists. It has to be in this file. These are nodes, puzzle nodes, and then these are the elements within the node. And then the puzzle parser, it reads each node, and then each element loops through that, flips through each node and then each element in the node, and then creates the puzzle object and adds it to the model. And let's see, we talked about sound a little bit, static methods, nothing impressive there. Puzzle class, really straightforward, just setting this up for the future, because you can have a lot of additional data that we can now include with puzzles if we have its own puzzle class, which was one of the last things I did, I think, in this iteration. We have hint dialog, which extends dialog. Originally, this code was lumped in with main game activity, and I split all of that out. You know, the animations is really just about controlling the x-axis and the y-axis. Java makes it easy. It's a high-level language, and so you can do fancy stuff without actually having to get your hands very dirty. A lot of tutorials out there on how to do the Android animation. It's pretty straightforward and simple. You just integrate that with the layout, and then the buttons will, I think you've seen it, but the solution buttons enter from the left, and the pull buttons enter from the left, and the solution buttons enter from the top here. And I use my own custom font to give it a little more playful look. And all the sound is displayed under raw. But it's been a fun class. I enjoyed this class probably more than almost any other class. I learned a lot. I learned I didn't like Android Studio. It's quirky, it's weird. It's made by a good company. I mean, IntelliJ makes a great compiler for normal Java projects, but this thing will lie to you. It'll tell you that you have problems in files when you don't. It'll tell you that the files are going to compile fine, and then they don't. And then after the fact, it'll say, oh, there's an error here. I haven't experienced that with other IDEs, but it was fun. It certainly is helpful to make your own game or app in this class, because otherwise you're never really going to fully learn how to really code, make your own app in Android. It's something you definitely learn best by doing. This is my final class in the program, and so this is by definition, the last presentation I'll ever have to give. This is kind of bittersweet, though. I'm not a fan of the presentations, but I do love the coding projects and things. So for all of you others out there, I wish you the best of luck in the program, and good